Okay, our next goal is going to be solving a right triangle. To solve a right triangle means to find all unknown side lengths and angle measures. You can solve a right triangle when you know either of the following. The first situation would be if you knew two side lengths. Second one will be if you know one side length and the measure of one acute angle. So basically, when you're solving a right triangle, you have some of the pieces of the puzzle and you need to find the missing pieces. And the goal is to basically have all three angles and have all three sides, and then you have solved the right triangle. So find all the missing pieces. So let's work one of these out. It says solve the right triangle, round decimal answers to the nearest tenth. And it looks like I have a triangle where one leg is 24 units and my hypotenuse is 25. And I got to find, I know this angle is 90 degrees. So I already got that one. So I need to find my length of this side, AB. I need to find the measure of angle A, and I need to find the measure of angle C. So here, let's jot that down. So AB is equal to something. We got to find that. The measure of angle A is equal to something. We have to find that. And the measure of angle B is equal to something. We have to find that. All right, so let's try this thing out. So step one, I know two of my three sides of a triangle, and thinking back, that should make you think of your Pythagorean theorem to find the missing piece. And my Pythagorean theorem, of course, states that a squared plus b squared is equal to c squared. Make sure that my c is always my hypotenuse. In this case, I need to plug in 25. And it doesn't matter if the 24 goes in for A or B. So I can say 24 squared plus something squared equals 25 squared. All right, so let's figure out what these values are. So if I have 24 squared, that's going to give me 576. So this value right here is going to be 576 plus b squared equals 25 squared. So let's type that in. So if I have 25 squared, that's 625. And to solve for b squared, we're going to subtract 576 on both sides. This cancels out. My b squared is going to be equal to whatever this difference is. And 15 minus 6 would be 9. 11 minus 7 is 4. Square root both sides, and we'll have our answer. B has to be 7. Okay, and by B, we mean really, AB here. So AB is equal to 7. So let's write that number right there, and let's put it in that red to be able to see it a little bit better. And we got one of our missing pieces. Two more to go. We need to find the measure of angle A and the measure of angle C. So with respect to angle A, I know that I have my opposite. So this is the side that is opposite angle A. And I know that I have my hypotenuse with respect to angle A. So if I'm dealing with opposite and hypotenuse, I should be thinking, all right, let's work with sine. So I know that the sine of angle A is equal to opposite over hypotenuse, which would be 24 over 25. If I want to solve for this angle, I need to do the inverse sine of my ratio of my sides. So I need to do the inverse sine of 24 25ths. And whatever that is, that will give me this angle A right here. So let's type that into our calculator. Inverse sine of 24 over 25. So I have the inverse sine of 24 over 25. And it looks like I am at about 73.7 on that. So this is an approximation. This is about 73.7. So the measure of angle A is about 73.7. So let's fill that into my picture right here. And this is a number of degrees here. All right. Now we have one more angle to go, and that's the measure of angle C. Before I do that, I just want to point out here real quick, I know I have three sides here, but if you ever have the choice between working with sides that were given to you and working with a side that you've come up with, you always want to work with your given information, because if you do that, if for some reason you messed up this side here, that mistake isn't going to carry over to this part of the problem. So that's why I chose to use sine the 24/25 there. Now with this angle C, I really have two ways to get that. So I know I have 180 degrees in my triangle, so I could do 180 minus the 73.7 minus the 90 and get that angle. Or my second option would be to take advantage of my trig functions. Since I'm getting some extra practice here with my trig functions, I'm going to work it out in that way. So with respect to angle C, this 24 is no longer my opposite, but with respect to this angle, this is going to be my adjacent side, and this is still my hypotenuse. So with respect to angle C, I know my adjacent, I know my hypotenuse. That's the ka part of SOHCAHTOA. So cosine is always adjacent over hypotenuse. So we can set this up as the cosine of angle C is equal to my adjacent, which is 24, over my hypotenuse, which is 25. If I want to find angle C, I'm going to do the inverse cosine of my ratio of my sides. So the inverse cosine of 24/25, and that's going to give me this angle right here. So let's pull up my calculator once again. So this time I'm going to do the inverse cosine of 24/25, and that gives me about 16.3. So we're going to fill in 16.3 right here. And this is a number of degrees, and that is going to be what my measure of angle B is. 16.3 degrees, and let's write it in here as well. And this is approximate. So let me add in. So this was approximately this. This was approximated as well. This was approximately, and just to do the math the other way real quick to show you that you get that 16.3. So I'm going to do, so 180 minus 90 would of course be 90. So I just need to do 90 minus 73.7. So if we take a look at that real quick, so if I do 90 minus the 73.7, notice I'm right back to that 16.3, which is the number that I have right there, and I am done. I have solved the right triangle. So AB was equal to 7 units. Measure of angle A was about 73.7, and the measure of angle C was about 16.3.